Welcome to the session on Algebra 2 Function Operations Part 2. And a function composition means that you're plugging entire functions in for the x variable. And these are the notations that you're going to see. And this is just to show you that these two notations mean the same thing as do these. So the first one we read as f of g of x. The second one we read as g of f of x. And basically you'll be doing the same things but in a different order depending on what the problem looks like, if the f is first or the g is first. So let's look at the first problem. Use the functions to answer the question. F of x is equal to x plus 1, g of x is equal to 2x. And we're asked to find f of g of x and g of f of x. So we're going to start with f of g of x, and what I like to do first is actually write it with just the parentheses. So f of g of x, and what we do is we start with the inside function, the one that is in the parentheses, the g of x. So what we're going to do, what this is telling us to do, is take the function g, which is 2x, and substitute it into your function f, completely replacing the x. So if we take a look at these two functions, f of x equal to x plus 1 and g of x equal to 2x, and if I look at making the substitution, I will be taking the function g of x, which is equal to 2x, and substituting it into my function f, replacing the x variable. So that means that f of g of x will be equal to, the x is being replaced by the 2x, and then we have the plus 1 from the function on the end. So the x is being replaced with 2x. So we get 2x plus 1 as our function for our composition for f of g of x. Now we're going to take a look at g of f of x. So I write it with just the parentheses, g of f of x, and this tells us to start with the function f. So you're looking at what's inside the parentheses, and the function f is inside the parentheses. So I'm going to be taking the function f, which is x plus 1, and putting that whole expression into the function g, replacing the x. Now we have to be careful here because this is 2 times x. So I'm going to be taking 2 times this quantity, x plus 1. So when I make the substitution, I have to make sure that I put parentheses around the x plus 1 because it's the whole quantity, and I want to show that the 2 is multiplying that whole quantity. So looking at the functions again, we will be taking function f, which is x plus 1, and we will be replacing the x, so it will be g of f of x will be 2 times the quantity x plus 1. Multiplying the 2 through the parentheses will give us 2x plus 2. And that is our answer there. Next, we have, given the functions f of x equal to 5x and g of x equal to x squared minus 1, we're looking to find f of g of x and g of f of x. So the first one, f of g of x, writing it in the parentheses, we have f of g of x, and looking at the two functions, we start with the inside g of x, so we're going to be taking g of x, which is equal to x squared minus 1, and we're going to be substituting it into this function, replacing the x. So you may want to pause and try this problem on your own, and then turn it back on to see the answer. So again, I'm starting with the inside function, which is g of x, and I am replacing the x in function f. So when I do that, I will have five times the expression x squared minus 1. And multiplying through the parentheses, distributing the 5 through the parentheses, will give me 5x squared minus 5. So this is my answer for f of g of x. So let's look at g of f of x. We're working with what's on the inside of the parentheses, which is the f of x. So I'll be taking the function 5x, and I'll be replacing the x in the function g. So I will have 5x replacing the x in this function, and the x is being squared, so when I replace the x with 5x, I'll be squaring that 5x. So I will have g of f of x is equal to 5x is replacing the x, and that is squared, minus 1. 5x squared will give me 25x squared minus 1 for g of f of x. Next, we're going to take a look at this problem where you actually are doing a number rather than an expression. So, we're doing f of x equal to 2x plus 3 and g of x equal to negative x squared plus 5, and I have to find g of f of 1. So g of f of 1, the first thing that we want to do is find f of 1. So what this is telling us to do is start with the inside function as we were in the past problems, but instead of doing an expression, we're doing a number. So you should get a number answer here at the end. So this is first saying to find f of 1. So I'm going to find f of 1 first, and to find f of 1, I replace the 1, or I replace the x with 1 in the function x. So I will have 2 times 1 plus 3, which will give me 5. From there, I'm going to take this 5 and I'm going to place it into the function g. So I'm actually going to be finding g of 5 next. So to find g of 5, what I do is I take the 5 and put it into function g, replacing the x, and you have to be careful here because it's negative x squared, so we don't take the negative sign away, we just replace the x with the 5, the squared is still there, and we have the plus 5 on the end. Now squaring this, it's not negative 5 squared, it's just 5 squared, so it's going to be negative 25 plus 5, which gives us negative 20. And that's my final answer, just the negative 20. And we're going to do the same thing with this last problem. It's f of x equal to 2x minus 3. Find f of negative 4. So, to begin with, we are finding f of negative 4. So f of negative 4 means that we are replacing the x variable with negative 4. So it'll be 2 times negative 4 minus 3, which will give us negative 8 minus 3, which is negative 11. From there, we're going to take that number and we're going to do it again. f of negative 4 means to first find f of negative 4, then take that number and substitute it back into your function f. So when I do that, I'm going to be finding f of negative 11. And I apologize because that's not the correct number there. So let me fix that. So it will be f of negative 11. So substituting the negative 11 back into function f, I will have 2 times negative 11 minus 3. So that will give me 2 times negative 11 is a negative 22, minus 3 gives me negative 25. So my final answer is negative 25. And that ends this session on function operations part 2.